we are going to solve and continue solving from where we left the last time. The first question we have, you will see some basic terminology that we are going to discuss in these problems, probably help you revise and pick up some concepts that you might have not remembered in our previous lectures. Okay, so the first one is the process or phenomenon that we wish to study statistically are commonly known as. So this is a very straightforward answer. So any phenomena or process that we wish to study is known as experiment. So we do experiments, we get the results. Okay, we're going to see more as we go ahead. So, and the set of all possible outcomes or results of any experiment is said to be the sample space. What's the all the total outcomes that you are hoping to achieve in an experiment? Okay. Next question we have. So, which of the following is a random experiment? Okay. So all the options listed, which is rolling a dice, tossing a coin, observing the number of goals in a soccer match, and observing the number of phones sold by an ABC store are examples of random experiment. So what is random experiment right here? A random experiment is any process or action where the outcome cannot be predicted with certainty before it happens. So there's unpredictability of outcome. So there is always an unpredictability of outcome when you are running an experiment. So rolling a dice, you will notice that you cannot be sure which number will come up. Tossing a coin, again, the outcome of head or tails is unsure. Observing the number of goals, a player can hit as many goals as he possibly can. Observing phones sold, so the number varies each year and can be predicted exactly. So you have all these experiments are random experiments. Next up, we have suppose there are N1 doors to enter a stadium and N2 doors to exit the stadium. One can enter the stadium through any entry gate and exit from an exit gate only. In an experiment, let the outcomes be the gate of entry and gate of exit. Then what will be the cardinality of the sample space? Okay, now let's do some explanation. Each outcome is a pair. Why is that? Because we have exit and we have entry. Okay, so we have entry door, we have exit door. If there are N1 entry doors, so N1 is your entry door. I think it's given here, yeah. And N2 is your exit door. For every way to enter, for every N1, there are N2 possible exits as well. So your total outcome is going to be N1 times N2. What does cardinality mean? Cardinality shows the sample space. Okay, how many total outcomes are there? So each outcome is going to be a pair. N1 entry, N2 exit. If there are N1 entry doors and N2 exit doors for every way of where to enter, you can leave through any of N2 exits as well. So total unique value or total unique ways or outcomes is going to be N1 times N2. So this is same as the multiplication rule. So if one event can occur in m ways, the other and another in n ways, so both will give you n times n ways. So what's the total number of outcomes? So your right answer is going to be this one. All right. Then we have option number 5. Consider the experiment of possibilities of runs scored by a batsman on facing pair of balls. How many sample points are there in the sample space when a pair of balls is being faced by a batsman, assuming any run from 0 to 6 can be scored off a single ball? Hmm. Okay. So we know there's an experiment of possibilities run scored by a batsman. Okay. How many sample points are there in a sample space when a pair of balls is being faced by a batsman? So possible runs are between 0 to 6. So each ball can result in any run from 0 to 6. That means a single ball has 7 possible outcomes. So single ball has how many? 7 outcomes for one ball. He cannot score any ball, one ball, two ball, three, four, five, six. Okay, so there are 7 outcomes. For a pair of balls, this is going to be 7 times 7. Because as you have seen before, the cardinality is n1 times n2. That's why you have n times n, which is 7 times 7. 7 outcomes in first ball, 7 outcomes in second. So total you have 49 outcomes. I hope this makes sense.